All right, we want to look at how we can form a cone from a sector of a circle. So this is our circle with a center here, O, center O. All right, this part of the circle is called major sector and this part is called minor sector. So we've split it into two, the minor and the major. Now we can use the minor to form a cone and we can also use the major to form a cone. And the cone will look like this, all right, as a normal cone that we know, all right. So this is what we can have, as you can see. But one thing we need to know here is that the radius of the sector that is used to form the cone is equal to the slant height of the cone, as we can see. The height of the cone still remains h, and the base radius of the cone still remains small r. So we can have a relationship between h big R and small r using Pythagoras theorem. So we can have r squared equal to h squared plus small r squared. So you can be asked to find r, you just make r the subject. You can be asked to find h, you make h the subject. You can also be asked to find small r, that's the base radius. Now this formula, we can also write it because if L equal to R, we can also say L squared should be equal to H squared plus what? R squared. So this and this are the same things that we can do. Now, let us look at the angle here. This angle here is called semi-vertical angle. And the whole angle here is called vertical angle. So we can be asked to find, that is the semi-vertical angle here, all right? And we can use our trig ratios, our sine, tan, or cos to do it. All right, so let's say we want to use our sine, opposite over hypotenuse. So we can say sine alpha equal to opposite, which is r. Hypotenuse, that is big R. By making alpha the subject, alpha will be equal to sine inverse the base radius of the cone divided by the radius of the sector. So after that, what we can say is that after we getting the semi-vertical angle, we can calculate our vertical angle by saying that our vertical angle is equal to 2 multiplied by the semi-vertical angle using our sine ratio here. Now, let us also look at how we can find the base radius of the cone. One thing we need to know is that the length of the arc, AB, okay, of the sector, this arc that is used to form this cone is equal to the circumference base of the circular cone. Therefore, the length of an arc, which is this arc we have here, that is theta over 360 times 2 pi, we use big R because we are talking about this arc, is equal to the circumference base of the cone, this cone. We use small r here because we are looking at this radius. This will nullify this. Then our radius of the cone will be equal to theta over 360 times big R. And that is when we are using this sector to form the cone. Then the angle here will represent at what we have here. If we are using this sector, then the angle here will be what we'll be having here. So whatever we'll have here, and we are looking for this, if this is x, then this will be 360 minus what? X. So we need to be very careful with this angle based on which part of sector we are using to form the cone. Then the volume of the cone will also be given as 1/3 pi r square h, as we studied. And the last one is that the total surface area of the cone will be equal to the curved surface area of the cone. So we can also use pi rl or pi r big R to find the total surface area or the curved surface area, because this cone form is a hollow cone. All right, so these are some few formulas that we can have here. All right, watch out for some calculations under cone. All right, let's see how we can solve the questions on the screen with the formulas that we studied so far. Now, we have been given a circle with a sector, all right? So this is the circle that we have. The sector will be a minor sector because the angle given in the question is 60 degrees, all right? With center O. And the radius of the sector is given, that is 22 centimeters. Here will be 22 centimeters, all right? So we can say that the angle given in the question is 60 degrees, and our radius in the question will be 22 centimeters. Now, we have been told that this sector here is folded to form a cone. So this is how the cone will look like nicely, all right? So with this is the height of the cone, the base radius of the cone, and this is the slant height of the cone, which is equal to the radius of the sector, which will be 22 centimeters. Now, let's see what we have been asked to calculate. Pi 2 is given, all right, as we can see, 22 over 7. And we have been asked to find the base radius of the cone. So what we can do is simple. How to find the base radius? We learned that our base radius of the cone R is equal to theta over 360 times big R, all right? Now, the angle is 60 degrees, so we have our 60 degrees all over 360 times the radius of the sector, which is equal to the slant height of the cone, all right? And when we break this down, we are going to have 1 over 6 multiplying 22. When we break this down, we are going to have, that is 3.6667 to 4 decimal place. But we have been asked to leave our answer in 1 decimal place. So the radius, that's the base radius of the cone, will be 3.7 centimeters. Therefore, we can conclude by saying that the base radius of the cone, that's the radius of the cone is equal to 3.7 centimeters to 1 decimal place. So this will answer our first question. Let's go to B. We have been asked to find the height of the cone, as we can see it on the screen. Now that we know our base radius of the cone, we know the slant height of the cone, we can now find the height of the cone, all right? So let us take our right angle triangle here. We have 22 centimeters. We have our H, and the base radius is what we've calculated here. That is 3.667, all right, to, let's say, 3 decimal place. We can use the 4 decimal place. Now, using pi here, as we study, we can say that 22 squared should be equal to H squared plus, all right, that's 22 squared should be equal to H squared plus, that is our radius, which is 3.667 all squared. Okay, so we are going to break this down, all right? So 22 squared will give us, that is 484, okay, H squared plus, when we type this on the calculator up to 4 decimal place, that will be 30.3956, 30.3956. Okay, so we group all our numbers at one side. So 484 minus 13.3956 equal to H squared, all right? So now we are going to subtract this. And when we subtract this, we are going to get, I think, 470 point, to 4 decimal place, we can say 6044, all right? So we find square root nicely, 470.6044. And when we find square root, of this number, we are going to have 21.6934. 21.6934 centimeters. Therefore, we can say that the height of the cone, all right, the height of the cone, that is to height of the cone to one decimal place will be 21.7 centimeters. So this is how we can answer the B. The last one, we want to look at how we can find the volume. So we studied that the volume of a cone, is equal to 1/3 times the base area times the height of the cone. So we are 1/3 times our pi is given 22/7. The base radius of the cone, as we solve it here, all right, we can say 3.667 to 3 decimal place, or we can leave it in our 4 decimal place. We are going to get the same answer. All right, so we are going to type this, all right, and when we type this on our calculator, that will give us 304 point approximately, we can say 4340 centimeter cube. And to 1 decimal place, as stated in the question, we can have 304.4 centimeter cube. All right, watch out for more questions on cone developed from a sector of a circle.